In this video, I'm going to do a couple of quick applications of antiderivatives based on applications of derivatives that we've already learned. For instance, tangent lines. In a previous video, we learned that we can find the slope of a tangent line by simply finding the derivative of a function. And so what we're doing now is we're working backwards. So what we are given is we are given the slope of a line. Well, we know that the slope of the line, which this is written as a function, we know that the slope is the derivative of the function. And so this, I'm going to write this like this, makes it just a little bit easier. X to the negative 1 is 1 over x. That is our function. And so if we want to find the actual function that this derivative came from, we need to find the antiderivative of that. And so as I've mentioned before, it's nice to just take the constant and put it out in front of the integration sign symbol. So we have 25 over 7 times the integral of 1 over x dx. Well, the antiderivative of 1 over x dx is the log of x. So f of x is equal to 25/7 times the log of x plus c. Oh, and by the way, this should not be there. The function is the antiderivative of this. Right now we need to find c. And so that's what we're given this information over here for. That information is to help us find our value of c. So we will plug in 4 for the x. This is basically our input or our x value, and this is our function value. So we'll plug those in here. We'll plug 49 in here. E is equal to 25 over 7 times the log of 4 plus c, or c is equal to 49 minus 25/7 times the log of 4. And that's going to end up being equal to 44. And so then a function, putting it all together, the function, now that we have c, the function is going to be 25/7 the log of x plus 44. That is the function that has a slope of 25/7 x to the negative 1. Okay, the next application is also based on something that we've learned in our lessons on derivatives, and that has to do with marginal cost. So we learned that marginal cost is the derivative of the cost function. And so now we're going to be working backwards. We're going to be given marginal cost. Right here is a marginal cost function. And we want to determine the cost function. So the cost function is going to be the antiderivative of 39x to the 8th plus 38x plus 30. And so let's go ahead and do that. We will have 39x to the 9th divided by 9 plus 38x squared divided by 2 plus 30x plus c. And so now to find c, we have to go back to the problem, and it says the weekly fixed costs. Now, fixed cost is just a fancy mathematical way of saying your constant, something that doesn't change. A fixed cost is something that doesn't change. Well, c is a constant. So in these cost functions, it's just kind of handy to remember that your fixed cost is always going to be c. C equals your fixed cost. So therefore, we can say that our cost function, and let's see, 39 over 3 is 9 over is 13 thirds x to the 9th. 38 divided by 2 is 19. X squared plus 30x plus our fixed cost, which was 77.18. And there we have our cost function. So these are two applications of antiderivatives, which essentially work in the opposite direction of undoing ideas that we've learned related to derivatives.